Okay,
Yeah,
so uh,
but
telecoigle,
yeah,
is my pronunciation is correct?
yeah, correct.
Okay, so my name is Kenta Murakami from the University of Tokyo. So let me introduce myself briefly. I'm an associate professor of the University of Tokyo, but the role of the research university in Japan is a little bit different from your expectation. We are something more like a technical support organization for the nuclear sectors. So my main collaborator is a regulatory body or the utilities. Today, all of my duty today is discussing with regulatory body people or something like that. But anyway, but the talk of today is nuclear safety, especially relating to the operational nuclear safety, increasing the capacity factor of the existing nuclear fleet or the future nuclear fleet. And I am really wanted to visit Tallinn, Estonia, because my colleague said that it was a very nice place. He visited there last year. But unfortunately, I have a very important mission for the enrollment of the university. So I'm apologizing to make a lecture through online. But anyway, first I would like to ask you about the how to say background of the audience. So maybe you are get a little bit tired. So please shake your shoulder and prepare for the raise your hand. So for the audience, how many audience who have a background of the biological science or the medical doctors or pharmacists, please raise your hand. None? Okay. Science, social science, physics, or the chemistry, or something like that? Okay, some. How about the engineerings? Engineering, mechanical engineers, electrical engineers. Okay. Or then this is almost all. And who is the minorities? Who is the minorities? How many minorities there? Okay, some. Yes, you must be a political background or the social science background. Yes?
Finance.
Finance. Okay, finance. That is very important. Most important in the nucleus. Okay, but when we start talking about the safety, we have to communicate with quite large, broad spectrum of the knowledge level, right? And the not only the residents, but also the workers inside of the nuclear power plant, they also have quite a diverse background. At the same time, the regulatory bodies people, I remember that in this morning you discussed about the importance of the human resources of the regulatory body, but the governmental officers or the regulatory bodies people, their knowledge level is also have some diversities. So when we start talking about the safety, we have to set some good basis for discussing about the safety. Okay? So let's get started. First, this is the very beginning point of the safety. Is objective of the nuclear safety defined by the IAEA, that is the protecting people and the environment from harmful effect of ionizing radiation. Harmful effect of ionizing radiation. So if we discuss about it for maybe 10 minutes, 20 minutes, then the basis become quite uniform. So what is radiation? Radiation is the energy emitted from the nucleus and transferred to the atomic system. Radiation is the energy transferred from the nucleus and has given to the atomic systems. Because the energy stored in the nucleus was shifted to the electron surrounding the nucleus, therefore the orbital of the electron will change. Then the distance between two atoms will be changed. This is a very fundamental physics, right? But if we know this, then we can guess what would happen in our body. Then when I start talking with the social residence people for the kind of kids school in the surrounding area of the nuclear power plant or the parents school in the surrounding area of the nuclear power plant, I start asking these people, which is true? Number one, radiation causes a cancer. Number two, radiation can use to curing the cancer, repairing the cancers, which is true. Actually, the answer is both, but the audience get confused, right? When we think about the mechanism of the radiation, energy transfer from the nucleus to the atomic systems, we can explain everything. First, in our body, the body was made of cell. And inside of the cell, there is a DNA, gene. And energy will be transferred from the outside of the cell to one atom in a gene. Then the atomic structure of the gene will be changed a little bit. This kind of change can also be caused by active oxygen or ultraviolet ray, of course the radiation, or maybe the anti-cancer drugs. Then the gene will be changed a little bit. But this phenomenon is very frequently occur, maybe 1 million times in one cell in one day. It's very frequent. But most of these change, atomic level change, will be repaired immediately based on these three mechanisms. First, atomic cell cycle will be arrested. Then DNA repairing mechanism will be actuated. And if it is accurately repaired, then the cell will be recovered. But sometimes inaccurate, incorrect repairing will be happened, but still the recovery will be happening, even though the repairing is incorrect. In this case, accumulation of the genetic abnormalities will be stored inside of the gene. When I discuss with the medical doctors, they said if they see genes, they can estimate the age of the cell, how old they are. Because when we grow, abnormalities is very small. But if they get old, then abnormality will be accumulated, not only the radiation, but also the many causes. So if they count the number of the abnormalities, they can guess the age. And if many of the abnormality was accumulated and something was started and the people become cancers. But at the same time, if we give too much damage in the gene, then the cell will be automatically be dead. Therefore, we can utilize the radiation for the cancer curing. So when we look at the internal mechanism of the genes, the radiation can be utilized both the cancer cause and the cancer curing, but everything was caused in the gene. And this diagram is very useful for explanation about the emergencies. Which path we should be worried about the progress of the accident? This path or this path, something like that. In case of the most of the accident, we don't have to worry about these mechanisms, because if we want to have this mechanism to cause the damage of the organs or the damage of the individuals, we need very large amount of the damage at the one time before repairing mechanism is finished. So for the workers, we have to worry about, sometimes we have to worry about this path, but for the residents, we don't have to worry about this path and only considering about this path. If we talk about starting from the microscopic mechanisms, the communication become quite frequent. And also the workers, it is very important to understand what mechanism is actuated for their safety. regarding this path, we have quite large number of static information, mainly taken by the third history of Japan, that is the Hiroshima and Nagasaki atomic bomb. X-axis is the level of the radiation, and y-axis is the relative risk caused by the additional level of the radiation. And I have to say that the maximum dose that the residents receive during the Fukushima accident is somewhere here. The people who was living in the Iidate village, staying in the evacuation area for the 1 month, those people receive in maximum this level of the radiation. And for the inside worker of the Fukushima Daiichi nuclear power plant, who was get in to the reactor building to open the ventilation valve for the suppression chamber for the emergency ventilations, these people receive this amount of radiation. For those 2 workers who has the highest radiation, their risk, relative risk, was increased based on the statics around 1.3 times larger than the norm. And for the residents, it is almost invisible. It is difficult to detect statistically. And this kind of information is all, accumulated in this website. This is the Radiation Effect Research Foundation's website, and everything was, this is in Hiroshima, and all information was summarized in appropriate manner, so you can use it. One more concern, social concern on the radiation effect is genetic effect, genetic influence to the next generation. We also have a quite large number of the statistics informations, especially after the long period survey of after the Hiroshima and Nagasaki atomic bomb. And this is the continuous survey from the 1967 to 1985, around 8,000 children born from the irradiated parents, and the other group with the same age or the same sexualities in the same decades. And actually, the number of the abnormal chromosome aberrations detected of these children is quite equal in the control group and the babies born from the exposed parents. So this is the clear evidence that for humans, it is very, very, very difficult to detect the genetic influence to the second generations, next generation. If the parents was irradiated and they are worried about having the babies, but such kind of effect is not detected statistically. And this information is also wrapped up in the research facility in Hiroshima. You can download it very easily. So please check it. So what I have to wrap up the discussion up to here, what I have to share to the related people, especially who concern the radiation effect, is that for the residents, only the long-term effect for the increasing of the cancer rate is question. This is only the concern for the residents, but the ratio of the increasing of the risk is quite small. But we have to carefully manage this risk by keeping the level of the radioactive material released to the outside, uncontrollably. if we release the radioactive material in large amount uncontrollably, we don't have any acute damage, but we may increase the risk of cancer in the long term. But even for after the Fukushima accident, the maximum dose is something like this for the residents. So it is quite difficult to detect, but we have to take care of these kind of effects. And that is the, how to say, common safety objective for all type of the reactors, not for the only for the conventional one, but also the advanced one. That is the basis of the discussion, reducing the uncontrollable release of the radiation. Okay? Well, this is my first thought of the talk, but if you have any questions or comment, I can listen at this moment. Do you have any comment or the opinion or the questions?
No.
Okay, maybe it is too easy, huh? Let's move on to the second one. The second one is talking about the safety design. Safety design. Well, let me start the quiz at the beginning for moving yourself. Okay? The quiz is very easy. Which is more dangerous? This is for the social communication. This is also for the social communication. Which is more dangerous? A coin. B, fusion reaction. Coin. Okay, some people. How about the fusion reaction? Okay, all of the audience is very mean or very clever. The answer is, there are a hidden part. That is, a coin in a baby's mouth and the fusion reaction in the sun. Of course, a coin is more dangerous. Why I want to say this is when we design the nuclear safety, the issue is so-called isolation. Isolation. Isolation is a technical term to make separate the hazard and the people or the environment or something like that who get that hazard. Source of the danger and receiving that danger, these two should be separated. That is so-called isolation. And how to keep the isolation is a basis of the safety design, as you may know, right? In case of the light water reactor or some other reactors, nuclear reactors, fission reactors, almost all the hazardous material, dangerous material, was kept in the reactor core. So if we could keep these all radioactive, dangerous material inside of the reactor core, then the isolation will definitely be secured. However, if something wrong happened and the isolation was broken in some reason, and the fission products, radioactive material will be released to the outside, then the isolation will be broken. So it is a failure of the safety design. Okay? When we want to secure the safety design based on the strategy, so-called the defense in depth, as you may heard of it, right? And the defense in depth concept is sometimes a bit, confusing. So we would like to have clear definitions. Usually, the light water reactor is, designed in a plant level. And the plant level, the light condition of the light water reactor is categorized into the four different groups. The first group is so-called the normal operations. And the last group is so-called design extension condition. And between the normal operation to the design extension condition, there are two more plant state, so-called AOO, anticipated operational occurrence, and the design basis accident. And the normal operation is a normal operation from the starting up, full power operation, shutting down, and refueling, or something like that. And design basis accident is accident for the safety design. We have to, when we go back to the light water reactor, maybe the BWX300, we have to consider at least two big failures. One failure is failure of a normal operation components. Maybe a piping connected to the reactor core to the turbine system, something like that. And the other failure is failure on the safety systems, emergency core cooling system or something like that, a part of the emergency core cooling system or something like that. For one normal operation system and one safety system was damaged, failed. However, the shape of the reactor core will be kept, and the radioactive material is fully inside of the reactor core. That is the basic concept of the safety design. So we call such kind of assumption in plant level is so-called design basis accident. And between the normal operation to the design basis accident, we have one boundary, so-called AOO. AOO is something like one mistake. One pump will be stopped, or one big mistake was happened due to the operators or something like that. Even if such kind of things is happen, we want to secure that the event will be progressed to reach to the DBA. So this is, we have a secondary defensive line between design basis accident and the normal operations. And mainly the protection systems will take part of AOO. And design extension condition. This is some extreme condition. We don't know the reason why. But reactor core was melted. That is something so-called design extension condition. Or we don't know the reason why, but multiple, quite large number of power supply will be lost. Or we don't know the reason why, in case of the PWL, the more than one steam generator was broken. We do not consider such kind of event in the design, safety design, but we don't know the reason why, but such kind of things happen. For that cases, we have to put some design feature to settle the situation. That is so-called the design extension conditions. In case of the nuclear power plant, we should define these four different of safety conditions, plant conditions, and confirm whether whole system will behave in the limitation of each criteria. That is the plant level safety design. And to fulfill this plant level safety design, the component level design will be defined. Because some component should be utilized, both normal operation and the design basis accident, for example. So this component is okay for normal operation in normal operations criteria. This component is okay for design basis accident, criteria. We have to confirm one by one. So when we talk about the defense in depth, plant level requirement and the component level requirement is sometimes mixture. So we have to be careful to communicate with the related people, both inside of the utility and outside of the utility, what and why the requirement was set. I forgot to prepare the quiz here, but I would like to give you one typical quiz for the safety design. And this quiz is my student who learned about the nuclear engineering in the University of Tokyo. More than half make a mistake. Okay. Inside of the nuclear power plant, there are many pumps. Some pumps is utilized for the circulation, normal operations circulation from the reactor to the turbine system. Such kind of circulations pump exists. This is pump A. The other types of the pump is the emergency pump. This pump is not utilized in the normal operation, but just for standby. And if loss of coolant accident happens, and this pump is start operating and push water inside of the reactors during the accident. This is pump B. The operators detect the failure of a pump. Which failure is more significant? Pump A failure, normal operation pump, is more significant, or pump B failure, emergency pumps failure, is more significant? Which failure is more significant? This is quite tricky questions. How do you feel? Pump A, normal operation pump. Okay, how about pump B? Well, some raise a hand. Okay, that is good, half and half, fantastic. The answer is pump A is more significant. Pump A failure is more significant. You know, if pump A failed, the situation, plant level situation, will be shifted from normal operation to AOO, one step more dangerous. However, if the plant is in normal operation and emergency pump was broken, but the plant will continue normal operation, right? If the operators detect such a failure, and they can just stop the reactor for the operation. Or maybe they will fix that pump quickly and continue the normal operation. Such kind of operation may be allowed. And no plunging from the normal operation to AOO will be happening. So when we consider about the pump level failure, it's a failure. And both the pump A failure and the pump B failure is important. But when we see the change of the plant level status, the normal operations pump failure is more significant. And based on this kind of consideration, the ranking of INES rating is set. And why I say this is quite often happen in not only Japan, but also some other countries. And utilities reported that we detect some failure of the pumps. And the newspaper or the TV start alerting that the nuclear power plant is dangerous. But if it is an emergency pump, and emergency pump, we have a redundancy. There are a lot of emergency pumps, and one of them is failed. then we can just repair it and continuously use it. However, once we detect the failures, everybody gets worried. So we have to make a good communication, separating with the system level transient and the component level failures. And the component level failure will be backed up due to another component. And the things that we have to be more concerned is plant level transient. Such kind of common understanding among the workers inside of the utility as well as local community is very important. And when we want to comprehensively understand such kind of things, we can use the probabilistic safety assessment, so-called the PRA. It's very simple. We have to categorize the failure into the normal systems failure or the emergency systems failure. And if both normal systems failure and all emergency systems failure happen, and the reactor core will be damaged. But even if we have a core damage, but primary containment vessel cooling function is secure, then containment will be safe. But if the containment will be broken, then the radioactive material will be released. So we can quantitatively assess the rate of the core damage or the rate or amount of the fission product release. But even if we have a fission product release, but the public can evacuate immediately, then no exposure of the public is expected. But if they fail, then the health effect will be happening. These kind of calculation can be done. Then in case of BWR X300, as you may know, this design is very in advance and almost no possibility of a loss of coolant accident. Length of the piping is very small and very immediate isolation valves existing in here. So if they detect the loss of the coolant, before they detect fully the core was exposed, the valve will be inserted in this position and the loss of coolant will be stopped. So theoretically, the no local design is a main feature of the BWRX300. And at the same time, they have a very strong passive system for emergency cooling. So once they lost the normal cooling line, there is the big heat capacity of the passive safety system, so-called isolation condensers, so that they can rotate the waters. So because of this kind of advanced design, these four categories may have to be changed a little bit, because local loss of coolant accident is the most important accident in the design basis accident traditionally. But in X300 design, we can almost ignore the possibility of the local. I think now the USNOC developed the reviewing guideline harmonizing both the conventional light water reactor and the advanced one, and how to treat each requirement traditionally developed in this kind of design concept, and how to apply it to the new types of the design. So you can follow this kind of discussion. But basic concept is the same. Basic concept is the same. We have to prepare 4 defensive line, and the third one is a design basis accident, and the first one is a normal operation, and we need 2 more intermediate lines. This kind of consideration is the same. All right, and the last one is, this is relatively new concept of the requirement proposed by the nuclear energy NEI of the US and confirmed by the USNLC. And the x-axis is the radiation amount, 30 days total effective dose received by the residents, and y-axis is the frequency of the event. So the NEI recommend to perform this kind of a quantitative assessment for the public exposure from the initiator to the public exposure. Because some of the design, they can almost ignore the possibility of the core damage or melting core or something like that, but they can calculate the possibility of the public exposure. So using the amount of the public exposure, draws a regulation line like this. This is the current proposal from the industrial organization, so-called NEI in the US, to the regulatory body in the US. That is so-called FC target. And what I have to mention is the maximum dose for the residents in the Fukushima Daiichi accident is, this is the 10 millisievert, so somewhere here. And the occurrence ratio is around 300, 400 years. So Fukushima Daiichi nuclear power plant accident is a little bit exceeding from this target, but something like that. So this is a harmonizing level between the conventional light water reactor to the advanced reactors. And if we want to set the equivalent regulations, one good indicator is a public exposure assessment based on the probabilistic safety assessment. This is the talk related to the safety design. This is the second third of my talk, but do you have any questions or opinions or comments on this part?
No comments? No answer?
Okay.
No?
Then let me move on to the last part of the talk. Last part is talking about the capacity factors and the operational safety issues. And both data was taken from the PRIS database of the IAEA. Different color is the different countries. X-axis is the year, and y-axis is, this part is the capacity factor, energy availability factors of the average of these countries. And this part, the x-axis is unplanned unavailability factor of the nuclear power plant, that is unexpected loss of the power. And the early year of the nuclear power plant, the capacity factor of the reactor is very low, not only in Japan, but also some other countries. They are all, the capacity factor is very low. And the main reason is some unexpected error or the failures for the relatively new technology in these decades. But you can, in case of Japan, as you may know here, the unplanned unavailability factor dropped down relatively very quickly in 1970s and keep quite low level up to 2000. It is very low comparing with the other countries. US and France, they have more unplanned unavailability in nuclear power plant, so that the Japanese capacity factor increased relatively rapidly. Of course, there are some difference of the regulation or something like that, so the maximum value is not so high, but this immediate getting down is one typical feature of the Japanese nuclear utility. And one reason that we can reduce the unplanned unavailability relatively quickly in the new nuclear power plant in this period of time is something that was explained in the morning lectures, the improvement standardization project coordinated by both government and the private sectors of private sector of Japan, and they wrap up all the failure or the trouble information, and share these kind of knowledge inside of Japan, coordinated by the government, and reflect such kind of cause of the failure to the new design, improved design of the one age newer nuclear power plant. This kind of improvement cycle enable to reduce the trouble quite immediately in the Japanese utilities. However, some troubles, as well as the earthquake, actually occur in this period of time, and the unexpected unavailabilities increase after the 2000, unfortunately. And when we want to secure the safety in operational status, the quality management is very essential. Quality management is very essential. And how to acquire the common understanding on quality management is also some challenging issues. And in latest concept, actually the ISO was improved in 2018, so this is 1 year's old version, but quality management system can be described into three sections. One is the process approach, risk-based thinking, and continuous improvement. And the basic concept of the quality management is we have to define the process. All workers have to work based on the defined process. And the process should be made to harmonize the expectation of the customer and the result of the process. These two should be matched. This is the basic concept of the quality management. And in case of the operational activities in the nuclear power plant, as well as all kinds of activities, the process should be defined, but we cannot write down everything on the contract. We cannot write down everything on the contract. So when we want to dispatch the people for one process, there should be background knowledge of workers. We have to give a tool for conducting the process, and we also have to define the procedure or something like that. But always there must be some deviation from the result and the expectation from the customers. And the expectation from the customers and the result, this deviation may caused by the lack of the knowledge, may caused by the environmental changes, may caused by the customers' changes. But we have to detect this deviation and feedback to the procedures and the process. This is so-called the management systems. And when we want to utilize the new technologies, the relationship between the top management, workers, and the technology suppliers is always the issues, always issues. Because we use relatively new technologies, we have to give the top management should give the orders, training, and the salary and so on to the workers. And the workers will supply the top management for the manpower and reporting. And during these kind of relations, the knowledge will be accumulated, both top management side and the worker side, and the activity will be improved. However, how about the technology suppliers, especially the new technology like this? Whether they can also accumulate the knowledge based on the operational experiences or not is a kind of a question. So the relationship between the workers and the technology supplier is also very important. And to have a good, mature relationship for the knowledge sharing, the nuclear industry developed the operational experiences process coordinations. And that is including the international information sharing services, internal reporting systems, and internal screening system of the report, and also the problem identification and the solving, and corrective action program, and feedback to the operational experiences. This kind of systematic approach is important. For example, the corrective action program, this is very interesting program, as you may know, but the corrective action program is the reporting of the worker to the whole plant members, including the plant superintendent. And in general nuclear power plant, in every month, around 300 or 400 internal report is written and submitted to the top management of the nuclear power plant superintendent. And with the plant superintendent, these 400 reports per month are screened quickly. And if it is ranked in a highest level, the superintendent himself should treat these issues. If it was rated to the grade 2, the vice superintendent should be treated. And if it was rated to the grade 3, the section head should be treated. Based on this mechanism, worker can report their concern directly to the top management of the nuclear power plant, and the top management can get the information from the workers. At the same time, top management will evaluate the workers' attitude or workers' tacit knowledge, so that workers also have a chance to be recognized by the top management. Based on this mechanism, both the workers and the top management have a benefit, and the knowledge will be dynamically accumulated inside of the nuclear power plant. So this is so-called the corrective action program. Finally, I'd like to mention about the leadership for safety. Because in around 2000, importance of the quality assurance become more significant in the society. And many people start saying that process should be well defined and the result should be predictable for satisfying the customers. And the information should surely be feedback to the process, and everything will be written down as a report or something like that. This kind of attitude was accumulated inside of the nuclear facilities, as well as some other sectors. And what was happened is, how to say, the workers was strictly follow the procedures and no room for improvement. No room for improvement. But what we want to have is accumulation of the knowledge and the continuous improvement. Continuous improvement. So we had to revise the system of the quality management in somehow and encourage the improvement more strongly. At the same time, we should, how to say, keep the structure of the quality management. And Professor Kotter, he is the professor of the Harvard Business School, and he made a very good effort for defining the leadership and combining the concept of the leadership into the quality management systems. Based on, okay, this is a last quiz. This is a last quiz for everybody. I think this one is a last quiz. Yes, this is a last quiz for everybody. There are two types of organization. Two types of the organization. Which organization demonstrate the leadership better? That is a question. And in this question, half of my students made a mistake. Half of my students made a mistake. Okay. The organization type A, there is a strong leaders. He is highly respected. He made the decision immediately, and everybody followed him quickly. This is organization type A. Organization type B, there are not good leaders. There are not, how to say, remarkable leaders. All organization members represent their ideas and propose the idea for the improvement. And they often discussing how to change the organization. Type A, strong leaders, quick order, quick response. Type B, no remarkable leaders, many discussions. Which organization demonstrate the leadership in better way? Okay, let me ask. Type A organization. Type B organization. Okay, yes. Today, audience is quite senior, so you can reach to the correct answer immediately. But for young expert in the university, they feel that the strong leader is something like the representing of the leaderships. And this is clearly defined in ISO 2009. Top-down approach is the lowest maturity of the leadership. And appropriate transfer of the authority to the people at all levels is the highest representation of the leadership. That is defined in ISO 9001. And the very important outcome of the Professor Kotter is giving a clear definition of the leadership in the context of the quality management. He explained that the leadership is a relationship to produce change. So to perform the leadership, what the leaders have to do is setting direction, aligning people, motivating and mentoring and inspiring. In contrast, the function of the management is coping with complexity. And the outcome of the management is the predictability and the orders. To get this outcome, he explained that what the managers have to set is a plan and a budget, how the manager should behave with the organizing and the staffing, and what the manager do is controlling the problem solving. So when we, how to describe the leadership is a big challenge in the nuclear organizations because we have a strict regulation and clear defined procedure for doing activities. So how we can cope with these kind of structure and having some changes is very difficult challenges for existing nuclear operators. And finally, I have to mention about the institutional strengths in depth. This diagram is proposed by Dr. Richard Mezard. He used to be a head of INSAG, International Nuclear Safety Advisory Board, advisory group for long years. After the investigation of the cause of the Fukushima Daiichi accident, well, in the IAEA Fukushima report, they reported that there is the basic assumption that nuclear power plant safety system is robust enough so that the chance of the improvement was lost. To cope with such kind of situation, the Dr. Mezard proposed for the institutional system to raise a challenge to both industry and the regulatory bodies and get accountabilities. At the same time, industry needs a good peer review mechanism and the regulatory body need a good peer review mechanism. This kind of national structure is very important. And how to make such kind of national system is one of the current challenge in Japan. And maybe based on this diagram, I would like to show several examples in later session related to the human resource development, because I heard that you feel that the making human resources for both the industry but also the regulatory body is a kind of a good challenges in your countries. And we also face such kind of challenges and trying to have some way to solve it. So I would like to share these kind of things based on the basic common understanding of what is a safety, what is a safety design, and what is a safety operation. Well, this is the end of my slide, I guess, and I talked a bit diffusingly, but I would like to share the Japanese experiences as well as the basics informations related to the nuclear safety. Thank you very much.
Thank you very much, Murakami-sensei. Okay, any questions for Dr. Murakami?
One thing I can tell is I'm the most free lecturer today because all other lecturers have their organization's responsibility, so they have something they cannot tell. But I can tell everything, so I can tell anything, so you can ask anything. Okay?
Yes, please, yes.
Hello, thank you. So has the culture in Japan changed in the management after the Fukushima or not?
It's a good question. It's a good question. Well, the definition of the culture is a bit difficult. And, well, let me say, maybe I should explain several examples. There is a very good report published by TEPCO in 2014. And there are a big discussion inside of the Tokyo Electric Power Company and why they couldn't prevent the Fukushima accident. That is an internal review report. And one important outcome on the TEPCO's report is what is lacked in the TEPCO is the technical skill to explain their concern to the society. If they have a concern, but they hesitate to demonstrate that concern to the outside. So they review their attitude in that manner, and they set a plan to change their attitude, and they try to make a communication in better way in how to represent their concern or the responding from the new findings. So it's a big cultural changes, and they are trying to do, but from my personal observation, they are still under the way. And similar situation is also be observed, not only TEPCO, but also some other utilities, because they have a strong responsibility to supply the electric power to the society. And the reliability of the energy supply is very important. Their missions, they are proud of it, and they are very, they are very good, they have a very good effort on that. But because of this effort, they have small hesitation to represent their concern that may reduce the reliability of energy supply. This is a big conflict between two important loyalty of them. And so it is big, it requires big cultural changes. Did I answer the question?
Yeah. Are there more questions? I have a simple question, Murakami-sensei.
Okay.
So you you mentioned the table on the level of the management leadership.
Leadership.
Yeah. Could you show me again?
Please. Yes. Yeah, I think I'm sharing now.
Yeah.
So, 多分would you please show the screen?
Anyway, my question is, you can point out the typical organization at the highest level in Japan.
None.
The other industries, not especially nuclear power, such as the University of Tokyo.
Maybe somewhere here. We are somewhere here.
Okay.
And our research reactor must be here. I'm always saying that our research reactor is the lowest level of the leadership as well as the safety culture. Because if we want the workers level, they behave the process strictly based on the regulation. They tend to behave like this. Important things to have a highest maturity level of the leadership. Always the proactive activities and the learning attitude or something like that is needed. And the University of the Innovative Organization have some advantage to show such kind of attitude. But still, the engineers always try to solve the problem, so they always tend to behave reactive. So we have to recognize the engineer's typical attitude and the weakness. We focus on solving issues so that we tend to behave reactive. It is a bit far from the leadership attitude. and especially in the nuclear organization. If we couldn't do that, the capacity factor will never be increased because, if we have trouble in normal operation, then we stop and fix and never increase the capacity factors.
Okay, thank you. Yeah. Anyway, the evaluation of level shall be other organization, others, not
Yes.
by yourself.
Okay. Okay. Maybe I can give one example. What TEPCO did is they hired the ex-CTO, Chief Technical Officers, relate such a high level of the engineer from Toyota to change their cultures. The TEPCO set Mr. Uchikawa, he was the highest level engineer in Toyota or a chief improvement officer in TEPCO, and he, teach around 20 chief improvement officer in all sections in TEPCOs. And these officers demonstrate the leadership and the improvement reflecting the manner of Toyota. We call it the Chief Kaizen Officer. Kaizen is a Japanese of the improvement. Chief Kaizen Officer in the TEPCOs, and they demonstrate how to achieve the leadership inside of the TEPCO. Try to change the culture, but still it's very difficult. But we can find some good example in the innovative section of the industry and get them and ask them to demonstrate the leadership inside of the organization. So finding the good example from the other industry is very important, as Kishida-san mentioned. Did I answer your question?
Yes, thank you. Okay, are there any more questions? Okay, thank you so much, Murakami-sensei.